Hello guys, again I'm here, your instructor Adnan Munir. Okay, so I hope you guys enjoyed the last lecture and you also just go through from the last lecture. And I'm gonna actually tell you in this lecture about the component of the computer systems. Again, I'm going to request you guys, please subscribe this channel and please share these videos with your friends of the computer system or computer scientists, other computer engineers, so that they can something whatever they can learn from this video and they can learn. Okay, so please share this video and please subscribe the channel so that you guys can easily access the data from my courses. Okay, so as from the last lecture, we study actually the high level assembly and machine language. No, in this lecture I'm gonna tell you about the component of a computer system. Okay, what are the main basic component of a computer systems. Okay, so we are gonna start about the computer. Okay, from this we can see, like, from there is a bus. What? Okay, there the question arises, what is the bus? As we know, bus is like a wire. Okay, in a system, in a computer system, let's suppose if we are going to deliver something, definitely we need something, to just to deliver that thing. Okay, so in the computer architecture, in the computer system, the bus is nothing, it just take the addresses, take the data from the different systems, and it deliver on it. Okay, it's actually an internal wire. Okay, so okay, there are the memory are the like memory, we have IO devices, we have control and data path in the processor. So the mostly processor is consist on the two things. Okay, the data path and the control. So we will study deeply what is the data path in processor and what is the control unit in the processor, but mostly the processor is consist on these two things, the data path and the control unit. Okay, and then memory and storage. Memory, like we have main memory and we have disk storage. Okay, so main memory, definitely there are different type of main memory as well, and disk storage, we have floppy disk, we have hard disk, we have USBs. So there are, so input devices, IO devices, it could be the mother, it could be the mouse, your keyboard. Okay, so these are input and output devices like monitor. And the bus, again, interconnect the process to memory and IO. Okay, whenever we are going to access the memory, definitely we need the address of the memory. So there buses are three types of buses. Okay, the memory, the address bus, the data bus, and the third is the control bus. Okay, so we will see deeply in our, because this is totally the introduction, we are going to study deeply in the next lecture, like what these are. Okay, and the network, there are network, it could be the external network, or it could be the internal network of the system, newly added component on communication. Okay, like Wi-Fi, it could be the Wi-Fi, it could be the wired. So network is network. Okay, so here it come the memory. What exactly the memory? The memory is nothing. It's a ordered sequence of bytes. Okay, like let me show you. Okay. Next slide. Here it is. Like here, let's suppose we have 8-bit. Okay, this is like 8-bit wide. Okay, this is like 8-bit wide. Each location is 8-bit wide. So this is 1 byte. Here it is 1 byte because it's 8-bit. Okay, so if it is 8-bit, this is like 1 byte. Okay, so this memory is nothing, it's a sequence of bytes. Okay, sequence of bytes is known as the memory addresses. Okay, so here actually the addresses, okay, if we can see from here, so addresses on my left side, it is given in the decimal format, and on my right side it is given in the hex format. Okay, it is in the hex format. Okay, so if we see from here, like we can see it's like 8-bit address, 8-bit address. Okay, so here it is like 8-bit address, but if here we can see like it's F. Each bit is a hexa bit. Each bit is hexa bit. And for the hexa, each bit is consist of 4 bits. Okay, hexa is actually, each bit is consist of 4 bits. Okay, so 4 bits. Okay, and here if you can see, you are seeing 8-bit, but these are not 8, because it's a hexabit. So 8 multiplied by 4, so maximum we can address how much? 2 raised power like 8 into 4, because 8 bit is consist of the hexa, so it is 2 raised power 8 multiplied by 4, which is nothing, which is actually 2 raised power 32. So 2 raised power here, which is actually 2 raised power 32. So we can address how many locations? 2 raised power 32. Okay, because it's starting from 1, that's why here it is -1. So because each, again, this each is consistent 4 bits, so 8 into 4 is 32. So maximum we, how many we can address? 2 raised power 32. Okay, and here byte addressable memory, because each byte has a unique address. Okay, as I told you, this is one byte, this is another byte, okay, this is another byte. So each byte has its own address. This byte has this address, this byte has this address, this byte has this address. So each byte has its own different address. Okay, so all processor have the same sort of the byte addressable memory. Okay, and what is actually the physical address space? Okay, it's actually determined by the address bus width. Let's suppose my address bus width, someone told me like your address bus width is 8 bit, someone told me 8 bit. Okay, so maximum I can throw my data, I can get access to raised power 8. Okay, but if my if we are considering here a Pentium, the Pentium has a 32-bit address bus. So definitely how much it can? 2 raised power 32. 2 raised power 32. So 2 raised power 32 is exactly a 4 gigabyte. How it become a 4 gigabyte? Because 2 raised power 32, I can write like 2 raised power, I can write 2 raised power 2 into 2 raised power 30. Can I write like this? It's like bases are same, power 30 and 30, it will count 32. Okay, and again here, because 2 raised power 30, 2 raised power 30 is known as a 1 gigabyte. Okay, so it will become 2 to the 2 to the 4. So here it will become, here if I write like this, so it 2 to the 4, so it will become like 2 to the 4 into 2 raised power 30, 2 raised power 30, so which is actually nothing, which is actually 4 gigabyte. Okay, so so it is like this, and that's why it's written as like. So here, physical address space, if someone asks like tell me the physical address space of this, so you have to see only the address bus width. Okay, as Pentium 4, the address bus width is like 32 bit, so it's like 2 to the power 32, which is actually nothing by only 4 gigabyte. I hope you guys understand from this like how it is like 4 gigabyte. Okay, this is for your understanding. And again, Ethereum with 64-bit address is definitely 2 raised power 64, and you can convert it into the gigabytes easily. Okay, and okay, this is, as I told you, like address space is the set of memory locations. Okay, what are the memory locations in bytes that can be addressed? So we, how many bytes we can address? 2 raised power 32 minus 1. Okay, this like we can address. Again, what is address, what is data, and what is control bus? Here we will see the address bus. I told you like there are three types of buses. Okay, address bus, it's actually, the memory locations. As I told you, like memory locations have different addresses. Okay, so the address bus will take the addresses of these memory locations. Okay, so the memory addresses are put on the address bus. Okay, let's suppose, if this is very interesting thing, if a memory address is equal to a bit, let's suppose if a memory address is a bit. Okay, so how many locations are addressed? 2 raised power a. Again, like if memory address, if let's suppose my memory address is like 8 bit. Okay, uh 8 bit, so I can how many locations are I can address? 2 raised power 2 raised power 8. Okay, so I can address 2 raised power 8. Okay, so it's like this. So this is like from the address bits, you can see like how many locations you are going to be addressed. Okay, data bus, as from the name we can see like Database, we are going to load the data, or the data what exactly from the memory, from the registers, from the cache. So data can be transferred in both direction. It's a bidirectional. This bus is bidirectional because we are going to load the data into the memory or register. We are going to store, we are going to load, or we are going to store into the location. So it's a bidirectional. Okay, so always the data bus is a bidirectional. Okay, and what is control bus? Control bus is actually control, like the read signal, write signal. Okay, from here you guys will understand. Let's suppose this is my memory. Okay, I'm going to write and read on this memory. This is my processor. Okay, let's suppose there is an address register. What the address register have? The address register definitely has the address of the instruction, or the address of the memory location from where we are going to load the data, or where we are going to store the data. So let's suppose there is a address. Okay, there is an address. How the system will know? How the system will know from this address? Either I'm going to store the data on this address, or I'm going to load the data from this address. From this address, how my system will know? Definitely these signals, these three signals. Okay, let's suppose if my read signal is one, if my read signal is one, all other signals will be 0 0. Okay, all other signals will be, definitely it will be the 0. And definitely, because done is 1, it will, when it will be 1, when our this process is done. Okay, when read is 1, definitely on this address, we will read the data, we will fetch the data, and this data will be load on the data bus. From the memory location, this will be load on the data bus. Okay, whenever read signal is 1. But whenever write signal is 1, definitely on this address, from this data bus, we are going to store the data in the memory. Okay, so these are the control buses. With the bus control, with these signal, we control actually what exactly we are going to load, what exactly we are going to store. Okay, when the process is finished, definitely done signal is 1. Okay, so I hope this is very clear to you guys. Okay, so again, the memory devices, we have two types of memory. Okay, the especially if it's like volatile memory devices, the volatile, it's not the permanent. Okay, so whatever is in the memory, when you are going to switch off your system, it's going to be vanish. Okay, and non-volatile, definitely whatever you have, right, it will stay in the memory, either if you are going to shut off, or not going to shut down your system. Okay, it will stay. So volatile memory, we have different type of volatile memory. Okay, like we have RAM, we have DRAM, and we have SRAM. Okay, RAM is nothing, it's like a random access memory. DRAM is dynamic random access memory. Okay, SRAM is static RAM. Okay, what is the difference between dynamic RAM and the static RAM? Okay, like very easy difference is like, in dynamic RAM, we store the bit, because after all we have to store the bits, definitely. So if I'll say, like, I have a transistor, I have a capacitor. Let's put this is my capacitor. The capacitor is nothing, it's a charge storing device. It's a charge storing device. Okay, and let's suppose I have here a transistor. I'm sorry about my trying, because up till now I don't have the tab. Soon I will get the tab, and my tab. Let's suppose this is my transistor. Okay, this is my transistor, and this is my capacitor. Okay, uh let me remove this one. Okay, so let's suppose this is my transistor and this is my capacitors. Okay, this is about the, I'm talking about the dynamic RAM. Okay, okay, so the capacitor is the charge storing device, but the capacitor store the charge for very very few time, like for some milliseconds. Okay, after some millisecond, this charge is going to discharge. Okay, this capacitor is gonna be discharged. So when it is charged, it is stored as a 1. Okay, when it is when it discharge, it's stored as 1. So we store our bit in this manner in dynamic RAM. And please Just think, it's only a one capacitor and transistor. In dynamic, it's a million of transistor and capacitor on the dynamic RAM. Okay, so I'm just telling about the one transistor and capacitor, so you can store one bit with this in dynamic RAM. Okay, but when it's going to be discharged, we definitely need again to charge. So every time after some milliseconds, because it's our capacitor is going to discharge, so we need some charge, we need to charge it again. So that's why it need to be refreshed, it need to be refreshed. So dynamic RAM is actually every time it has to be refreshed. Okay, so here it's written like one transistor cell and one trench capacitor, and it's dense but slow. Okay, must be refreshed. Like, this is like how must be refreshed. As I told you, we must have to refresh. Okay, and a typical choice for main memory. Okay, for main memory mostly we use the dynamic RAM. Okay, and about the static RAM, like these type of six transistor cells make only store used for storing six. It could be four, it could be six. Okay, for storing only a one bit. Okay, for only storing one bit, one or zero. Okay, it is faster, but it's less dense, because for only one bit we are covering like this type of six transistor area. Okay, so that's why. uh, and it is mostly used for the cache memory. What is the cache memory? We will see, inshallah, but the mostly I'm going to tell you the cache memory is inside the processor. Okay, again, the non-volatile memory, these actually store information permanently. Okay, it's not going to be vanished when you are going to switch off your system. So ROM is nothing, it's a read-only memory. Okay, it's a ROM, EPROM, erasable programmable ROM. It's these all are the type of the non-volatile memories. Okay, there it could be the flash memory as well. Okay, so flash memory can be erased electrically in blocks. Okay, so it was the this was the memory devices. And in the magnetic disk, inshallah, we will see in the next lecture, because it's gonna be dense. I hope you guys enjoy this lecture and you guys learn exactly the devices and the components. In the next lecture we will see from the next lecture we will see about the hard disk and the remaining component. And guys, again, please, if you have any comment, please tell me in the comment section. And please share this video with your friends, and please subscribe the channel. It will boost me up to record the these type of videos. Thank you very much. Thank you very much, guys.